Our project is titled Identifying Recovery Rates After Hurricane Katrina. Our group was made up of Jessica Briggs, Mitchell Reel, and Melody Sipe.
In August 2005, Hurricane Katrina reached land, destroying a majority of the Gulf of Mexico. For this research, the focus was centered around New Orleans and how wealth disparity impacts recovery rates. Billions of dollars are spent annually as a result of these natural disasters. Many people who live in areas of greater risk rely on different agencies and organizations to prepare and aid communities for disasters. If these groups were able to identify the areas that would be most impacted, then they could focus their efforts on those places even before the storm occurs. Communities. Then the data was collected that represented different economic measures, and it was used for drawing conclusions about wealth disparity and recovery rates. This data was programmed into Excel and graphed. It includes verified loss for each district, renter statistics, and owner statistics.
The Normalized Differential Water Index, or NDWI, equation has two forms. The form used in this analysis compared the green and shortwave infrared Landsat bands. This form is commonly used to track changes in water level, so it was also appropriate to use in tracking wetness and flooding in urban areas. The equation shown was used in R to calculate the NDWI for each pixel in the downtown New Orleans area. This information was then displayed in a raster and overlaid over OpenStreetMap. This combination was then cropped to allow for analysis based on neighborhoods and their variation in poverty levels. Landsat data for multiple dates prior to and following Hurricane Katrina were used to analyze flooding and recovery times.
With knowing Hurricane Katrina's path, we were able to download compressed New Orleans district data with various things attaining homeowners and renters and median damage data. By sorting this data by relevance and creating graphs in Excel to show a clear picture, we could then apply this data to the poverty map we downloaded and cross-check different scenarios to see what effect of poverty had on each scenario listed in the graphs. With knowing damage data, we could then connect the USGS Landsat data in and draw some conclusions which are discussed in results. The two graphs I created and represented in the final project was renter versus owner and the SBA median verified loss per district.
It can be observed that most areas in the city north of the river are dry, with no deep reds indicating more standing water. The next image is from August 30th, 2005, one day after Katrina's landfall in New Orleans. Most parts of the city, especially those at lower elevations, have a large amount of flooding. It is worth noting the large blue rectangle in the center left of the image. This area of almost no flooding corresponds almost perfectly with the areas of highest income in New Orleans. This next scene is from September 17, 2005, 17 days after Katrina's landfall. Almost all areas, except for a few parks, are dry by this date. This final image is from September 1, 2006, 1 year after the storm. The areas shown here in red correspond fairly well to the areas of the city with the most poverty. This image shows why storm recovery can be so difficult for the lower income areas of New Orleans. Since they live in the most flood-prone areas, the next disaster is likely to come before they have recovered fully from the last one.
In the results, we were able to show that through the analysis, there is some evidence that people living in the areas with high poverty rates are also more susceptible to increased flooding. What was found is that in these areas of increased flooding, increased probability are those areas at lower elevations, especially those sitting below sea level. Because of this increased risk, property values in these areas are lower and more low-income populations move into these areas. Then when a disaster occurs, they are hit most heavily and have the slowest response time to recovery due to the lack of wealth in that area, which can be seen in the USGS maps that space out times before to up to a year following the hurricane event. One can compare some information between the poverty maps and graphs shown. First, looking at Lakeview on the poverty map, we see that the district has less poverty than the U.S. average, and their verified major loss was less than most other districts within New Orleans. Village D East has an average amount of poverty, and their median verified major loss was also relatively low. New Orleans/English Turn also represents the low poverty level and low verified loss. What seems surprising to us was that there doesn't appear to be a relationship between the poverty level and whether residents are renting or owning their property. We think this is because New Orleans is a city for young adults and college students who plan on only staying for a few years. We believe this is why the population also fell dramatically following the event and in 2019 is still not back to its pre-Katrina population. Some examples showing this conclusion, for example, include that in Lakeview there is a below average poverty level and most of the residents are renters. This data did not give us any specific answers but gave us ideas on places to investigate and see what the data appears to show occurred. To investigate further, we could look at the value of homes being rented or owned in each district. By looking at the flood maps, one can visualize the areas that were flooded before and a few different instances after hurricane's landfall, and compare these instances where low-income communities shown on the poverty maps stay flooded for longer following the hurricane's landfall.